To graph the following trigonometric functions, we're going to graph at least 2 periods of each function. We're going to draw any vertical asymptotes on the graph. Use the graphing calculator to confirm the accuracy of your graph. Make sure that you label the x-axis. So on this particular problem, y equals 2 secant 2x minus 1. As we start this, the first thing that we're going to look at here is the fact that secant is the reciprocal of cosine. So we're really going to graph y equals 2 cosine of 2x minus 1. Starting off with our period. Remember, we're going to take 2 pi divided by the number in front of the x, which is 2. So our period is pi. Vertical displacement, we have minus 1. We're going to move the graph down 1. Reflection, we do not have any reflection in here. Jump down to the range for a minute. Not quite yet, sorry. For the domain, we're going to have all real numbers such that then it's x doesn't equal something times n. So we're going to have to fill in that something in a few minutes, where n is. And then we'll have to finish that sentence with an odd integer or just an integer. So when we go ahead and start to graph, let's put in our midline here at the down 1. Not dealing with phase shift. So if we need to, we can have that in there. But we're going to graph like we're graphing a cosine function. So when we start here, instead of going 1 space up from our origin, we're going to go 1 times 2. So that's going to put our point here. 1, 2, 3, 4. We're going to finish here, which, by the way, is at pi. So we went 2 above the midline. We're going to go 2 below the midline, and then we've got our values here. Well, now that we've got the picture in there, what's going to happen is we're going to draw in our asymptotes. And we're going to draw in our asymptotes. But we have 0. And once we get that pattern, we can continue to keep drawing. Here's another place. And here's another. And we can go back the other direction. And these are just a bunch of asymptotes. I know it says that we only need to graph 2 periods. But once we find the pattern on here, we can graph as many as we want. So now that we have that, we can put in our values. There's 1 period. Here's the start of another. There's 2. And we can keep filling in our values here. Because we found the period. Sorry, that one's not very good. And over here. And I know we could have a partial to the far right and a partial to the far left. But as I go back in here and label a little bit more clearly, again, once again, I did 1, 2, 3, 4, and I call that pi. But what I really need to know is, what is my first positive asymptote? And my first positive asymptote, if 1, 2, 3, 4 is pi, means that my first positive asymptote is pi over 4. And we say that that's pi over 4 times 1. Well, then the next asymptote would be a pi over 4, but to get to that, we have to multiply by 3. And then our next asymptote would be pi over 4, but to get to it, we'd have to multiply by 5. And the values that we're looking at are the 1, the 3, and the 5. And what we see is that 1 and 3 and 5 are odd integers, so that we're going to fill in pi over 4n, and n is an odd integer, and our range. Well, our range is negative infinity to negative 3. Remember, go from low to high, joined with 1 to infinity.